Okay, I hope everyone can see. Okay, and I think she has already explained about the basic into my basic profile. Mm, Actually, after graduating from Japan Advanced Institute of Science and Technology, I was working in the Tokyo Polytechnic University about 4 years, then moved to Taiwan. And I'm happy to be here today. And today we are going to talk about the bit AR, VR, and XR. But I have heard and surveyed about Sri Lankan academia and the industry. Some of them already working on AR platforms and many AI applications. But I have heard about the VR and MR or XR still minor focused, or people is still they don't focus too much about the developing virtual reality application. And uh, let's see what is a VR, AR, VR, MR. What do you think about it? Because when we are hearing, every part has a R. Then augmented reality, virtual reality, and mixed reality. Um, you can see the reality, and that part is the mostly we are going to talk about. The abbreviation of the virtual reality came long time ago. The actually it's a set of images and sound produced by a computer that seems to represent a place or a situation that person can take part in. That was the formal definition about the VR. But after this definition, now we have came very long way. And when we are hearing about just a VR, always we felt that, oh, there's something, maybe fantasy or something, a different world we can see through the head-mounted display. That is the very beginning, very first impression about us. But actually, it was long back. People were um, trying to introduce a new space or new reality to make entertainment. Like a Zoetrope, over 100 years ago, people would like to make the animation tools or animation device that can generate something immersive space for people. But in 1960s, the engineers were invented the sensorama for engaging with the three-dimensional images, wide vision and motion, color, stereoscopic sound, aroma, wind, vibration. Actually, it is not really new for us today. It's 1968, 1960s, early 60s. People, researchers were trying to make it this kind of a different world or different space for people to engaging and entertaining. And but today, when we are hearing, there are mostly our mind and our interest going to head-mounted displays, maybe Oculus. Some people talk about Vive, HTC Vive, Vive Pro, Microsoft HoloLens, Google Cardboard, different headset always talking. But today we are going to a little bit clear about these, the misunderstanding about that. Actually, virtual reality and augmented reality, mixed reality, we can separate um, like this way. This is a very basic separation. The fully artificial environment, or like a believable reality made by the computer graphics techniques, or engaging with the hardware devices to give the full immersion in virtual environment. But augmented reality is the virtual object that overlaid on a real world environment. We can enhance the real world, the contents with the digital objects. Probably by the handheld devices, we can see the real world, some space. That space were enhanced by the 3D objects or virtual contents. Recently, we have heard that HoloLens and some other extended type of lenses that can interact with the real world and also meanwhile we can see the virtual object or three-dimensional contents. But a mixed reality we call the Emma, that can be kind of like the virtual environment combined with the real world. It's quite a little bit different with the augmented reality. Augmented reality, we cannot be fully inside the virtual world, but still keeping the augmented contents, but still we can immerse the virtual environment as we interact in virtual reality. Therefore, we call this the mixed reality, just this augmented reality and the mixed virtual reality that can combine together to interact with the both real world and the virtual world contents. That is the basic separation and basic how to say basic borderlines about these three realities. And let's see about the what is the use of AR, VR, and MR. And the very basically, or I mean, the early 90s, I mean, heritage site museums are the best place for use VR, because content is constructed content, or maybe the paintings, recreations, these kind of the new form of reality we can reproduce in museum and heritage site using the virtual reality. And this is one of my colleagues who developed the system, Professor Hong. He was in Taiwan University of Taiwan University of National Taiwan University. His early development was used the immersive VR to interact with the virtual contents through the VR controllers. And then other field is just kind of like a training devices. We can use VR, for example, motion capture or the film. People want to make the training or performance of the body performance capturing, but problem was the the performer cannot imagine the contents. Then it's need a visual cues or visual some support or reference to imaging. And then the virtual reality is the best way we can provide, like a dinosaur or any enemies chasing her, then her body the realistically react for the contents what she can see inside the virtual reality headset. And then later we can capture whatever film we need in any of the angle we need. And then other kind of a training, like a more extended mixed reality, we can use the virtual real via virtual contents and also real content for the for training purpose, or like the high altitude training workers, they are working. It's pretty hard for them to imagine or get a train in real world, because one thing is dangerous, other one is lack of experience. Then this type of mixed reality or VR content can be used for training purpose, and sometimes assembling, and meanwhile operations. So maybe the medical industry, to get a train for the operations. People can train by using virtual reality and or mixed reality contents, the systems. And but also not only the hospital operation, but military operation also. Another the training operations, we can train the people or guide people to face the unseen or uncertain situations that can generated by the virtual reality systems. And the therapies for like kids, to give the for some memories or recall the memories, or sometimes give the like contents they can touch. If we ask them to do some exercises or upper limb exercises, it's pretty hard for them to guide by using the hospital stuff. But if we can use the virtual reality contents, we can spontaneously guide them to do the specific task for a therapeutic purpose. And like the elder people, so today elder generation is getting increasing every day, and some of them are staying in the daycare centers. It's pretty hard for them to engage with their grandkids or other occasions. Early they visited some places. Then the therapeutic purpose, we are or extended or even some extended contents in augmented reality, maybe kind of a therapeutic purpose. We can use it. It's easy to use that. But problem is there are many limitations. The vision problems, to corrected vision, corrected content for the different age groups we have to do. We will talk in the future slides about that part, about the generalizing virtual reality contents or VR contents. And then the entertainment industry is the best industry in the world. We can use for the VR contents, for example, 360-degree movies, for reality shows, 360 reality shows. Even we cannot join today, especially a Corona period. We cannot join Oscar. We cannot join any other festivals. But still, we can use the virtual reality techniques to participate virtually, and we can see the real-time streaming 360-degree contents via mobile. We can join the even very close to the red carpet. That is the one of best way to engage the world audience to the world leading occasions, especially like dancing stars or maybe film festivals. Very entertainment occasions, we can use the virtual reality techniques. And this one everybody knows. I think you guys are very young. You're already digitally born people, and you are always gaming. And I hope that you are always entertaining with the somewhat extended reality with the everyday devices. And but today, most important thing is the design industry or design field. That part is the most important thing because industrial or mechanical or housing design or mechanical design, more high-end aircraft design part for different purpose like learning, teaching, and marketing. We can use the for example, like today, maybe even in Sri Lanka, some architects, they also use the three-dimensional design in CAD design, CAD models, trying to show that after building your home looks like this, or just try to negotiating the contents with the customers. That part also people still can use, but it's not so the still Sri Lankan industry is not developed that level, but actually still they are developing the contents. Then contents can be transformed into the virtual mode or the AR mode. It would be a great opportunity to attract more customers and then get the customer feedback and customer what customer needs. Both parties can realize especially customer requirements and also the cost-effective issues. They change in the material or like interiors, how much it will be, but the effect of the material they can realize through the contents. And then sales is the most part. I mean, marketing. The people can see what is the how they can be in the maybe Dubai. She's going to buy a house in Dubai, but she doesn't want to go to Dubai to check the house. The real time she can see the inside, and then maybe she can decide whether she's going to buy that apartment or going to change some part or negotiating. Therefore, VR is one of VR and MR, this field now already matured. And but unfortunately, in our country, the still VR is very how to say initial stage. And but I know I have heard about the augmented reality. AI is still pretty good situation in the especially for marketing purpose. Some companies, small startups, they are going to use. And but let's see the future, what it will be, how what's going to be I mean what will happen in 2025. And according to the recent report from the BYN's research, the institute, they have released the recently the forecast, the the future market. I mean, the virtual reality and augmented reality market is about 161 billion by 2025, and that means especially for the Asia Pacific, and also this figure it doesn't show, but Europe also highly engaging in VR, especially France. 1990s to 2000, the VR market in the Japan and Asia Pacific a little bit down, but the France, they were developing, they would keep carrying the research about the virtual reality. But today, boom is happen in the Asia Pacific, and Japan, Korea, Taiwan, and the China. This the Asia Pacific countries, they are really engaging in research as well as in the marketing, engaging in the AI and VR market. And let's see the video about the future of AR, VR, and Emma. That is going to be a one extended reality that is we call XR.
As curious beings, it's in our nature to wonder about the future. Even when we think about the past, it's only because we are hardwired to find patterns so we can better predict future outcomes. The driving force that shapes almost every aspect of the future of our civilization is technology. It's a gripping thought when you realise that for most of the time in human history, the lives of our ancestors were not that much different from their previous generation. The human species is about 200,000 years old, and most of that time, humans were hunters and gatherers. Even after we developed civilization, after the invention of agriculture, the lives of ordinary people living in, let's say, the first century of the Common Era remained relatively unchanged compared to people living 1,000 years later. Civilization shifted into the next gear only when the Industrial Revolution kicked in. In a span of only 260 years after the first Industrial Revolution, technology transformed our lives more than ever before in the history of our species. Most science fiction movies portray the lives of people living in the future with fancy gadgets and equipment, fulfilling all of our needs by command. Perhaps the first technology to mimic such a scenario and make us feel like we are living in the future is going to be the use of XR, or extended reality. So, what is exactly XR? To better understand the prospects of extended reality and its applications, we first need to learn about its constituents. XR encompasses a conglomeration of virtual reality, augmented reality, and mixed reality. First, let's take a look at the most familiar one, VR. Virtual reality is the use of computer technology to create a simulated experience that can be similar to, or completely different from, the real world. Standard virtual reality systems use either VR headsets or multi-projected environments to generate realistic visuals and sounds. The VR headset, with its user interface, offers you a digital experience that you can immerse yourself in any created 3D environment instead of just watching on a conventional 2D computer screen. Some early prototypes of virtual experiences predate even digital computing. Morton Helling wrote in the 1950s of an experience theatre that could encompass all the senses in an effective manner, drawing the viewer into the on-screen activity. In 1962, he built a prototype of his vision called Sensorama, along with 5 short films to be displayed in it while engaging multiple senses such as sight, sound, smell, and touch. Today, there are countless companies producing VR headsets. Among the most popular ones are Sony's PSVR, the standalone Oculus Quest, Valve Index, HTC Vive, etc. Obviously, gaming is the major industry propelling VR forward, but there are other fields beginning to incorporate virtual reality, such as education, medical training, and healthcare in general, the military, etc. If you want to learn more about this subject, we've uploaded a previous video solely dedicated to VR that's being suggested to you at the top right-hand corner. But next is augmented reality. In contrast to virtual reality, AR is an interactive experience of a real-world environment where the objects that reside in the real world are enhanced by computer-generated perceptual information across multiple, if not all, sensory modulars. AR can be defined as a system that fulfills 3 basic features: a combination of the real and virtual world, a real-time interaction, and accurate 3D registration of virtual and real objects. The overlaid sensory information can be constructive, additive to the natural environment, or it can be destructive, meaning the natural environment is masked to show virtual objects. In this way, augmented reality alters the perception of the real world, whereas VR completely replaces the user's real-world environment, a simulated one. There are many camera-based AR apps you can use with your smartphone right now. If you happen to own an iPhone, you can download the Measure app from the App Store for free. This app enables you to quickly measure the size of real objects, a person's height, and it can automatically provide the dimensions of rectangular ones. IKEA also came up with an AR app called IKEA Place, which lets you place virtual furniture in your house by simply taking a photograph of your physical space. Perhaps one of the best free AR apps out there is Jigspace. This app allows you to explore interactive 3D objects of just about anything. The library includes a mixture of fields such as machines, science, how-to, space, and even history. If you want a more in-depth video about this topic, check out our video about AR on the top right-hand corner. And finally, the last in our short list is mixed reality. MR is the merging of real and virtual worlds to produce new environments and visualizations, where physical and digital objects coexist and interact in real time. As the name implies, mixed reality is the mixing of the real and virtual world. MR does not exclusively take place in either the physical or the virtual world, but is rather a hybrid of the two. MR is similar to augmented reality, but there is a key difference. Mixed reality allows virtual overlay of graphics to interact with the real world. On February 2019, Microsoft released their new pair of mixed reality smart glasses called HoloLens 2. In this showcase, they demonstrated their MR smart glasses with an application created with Unreal Engine. 2 months after the announcement, the HoloLens 2 emulator also was made available to developers, which allows developers to create applications for this MR device. The HoloLens 2 has a diagonal field of view of 52 degrees, with a resolution of 47 pixels per degree, improved hologram stability, new hardware, and accelerated workloads such as eye tracking, fully articulated hand tracking, semantic labeling, spatial audio, etc. However, this device is not currently meant for consumers, as its price is enormous, costing $3,500. In your top right-hand corner, you can find a more detailed video about MR. And there you have it, the 3 main realities that compose extended reality. That's why there is a need to improve this technology and come up with an XR device that encompasses all 3 realities. Instead of having a different device for each realm, a VR headset, an AR-compatible device, and an MR headset, the market will eventually produce an affordable device meant for consumers that has all realities. One device. On May 2020, Qualcomm, the company that makes the chip for the Oculus Quest VR headset, came up with a huge announcement. They will start collaborating with 15 world-leading operators to deliver XR viewers. These operators plan to make XR part of their 5G offerings for consumers and enterprises within 2021. The XR viewers, as they call them, are lightweight, head-worn glasses that connect to a smartphone powered by Qualcomm Snapdragon 855 or 865 mobile platforms. Tethered to a 5G-enabled smartphone via USB-C cable, XR viewers unlock a new generation of immersive experiences using 5G-enabled smartphones that provide high bandwidth and low latency, which is essential for high-quality XR. On their website, it states, consumers' favorite smartphone applications can become augmented reality experiences in front of their eyes, or workplace meetings can be revolutionized through holographic telepresence with virtual collaboration platforms, as XR and 5G come together to transform how the world connects, communicates, and consumes content. To protect the market of XR devices and ensure software and hardware optimization, Qualcomm has an XR optimized certification program, which includes 6 degrees of freedom, head tracking performance on the viewer and smartphone, display calibration validation for the viewer, motion and photon latency validation on the viewer and smartphone, power and thermal test on the viewer and smartphone, interoperability between the viewer and smartphone. Within 1 to 4 years, they expect XR viewers to become wireless, while in the next 5 to 10 years, we will probably have 5G tethered glasses. The tech company that designs GPUs is also focused on the development of XR technology. Their Cloud XR is their core platform for streaming virtual reality, augmented reality, and mixed reality content from any open VR or XR application on a remote server, cloud, data center, or edge. Whether rendering complex graphics, stitching together 360-degree video, or rendering volumetric scenes, the Cloud XR streaming stack lets developers leverage a flexible, high-performance cloud. Nreal Light are the first light layer mixed reality glasses that look like normal glasses but offer the capability to blend in both the real world and with mixed reality world. They offer a 52-degree field of view and weigh only 88 grams. They come with a computing pack and controller, but can also be tethered to a smartphone. And perhaps the best part about the Nreal Light MR glasses is that they come as a computer kit package too. With the development of these many XR devices, future technology in general looks very bright. Did you like this video? Then show your support by subscribing, ringing the bell, and enabling notifications to never miss videos like this.
Okay, I think I thank those Science Time video. It has already a very good summarization from the history to today's history to future extended reality. And let's say, because the concerning about the Sri Lankan industry, how can I teach you guys about the pipeline and regarding the content creation for the AR, VR, MR? How can we engage with the contents? Let's see how can we build up that pipeline, discuss in detail. And then first of all, what we have to do is we have to hijack the each sense by replacing the natural stimulation with artificial the stimulation that is provided by the hardware, or maybe called the display, maybe handphone, or maybe the tablet, or maybe the head-mounted display. Using computer means like we can use the laptop, or maybe the other virtual reality devices we can use. Then basically what we have to do is somehow disguise our brain or hijack our vision, and then it can make activate the neural pathways, and then brain configure what we are looking, and that part is the most important part. Then to trigger or to change, I mean the configure our neural pathways, most important thing is we have to make the believable reality. Otherwise, our brain can understand, oh yeah, this content is not fit, or maybe content is so bad, wacky and very hard to believe. And then the most important thing is communicating with our brain. That part is very important before designing anything. And then we have to think about the total pipeline, whether we are going to do the mobile part or we are going to be the hardware part or PC based or cloud based, we have to think. And the basic design is from the content is from the art reference or um, any kind of reference. The basically I put here art reference because most of the contents maybe imaginated contents we have to reconstruct. Of course, we need a storyboards or maybe we need the event board to generate the contents. Then this part is a pre-production part is very important as usual. Digital content creation. So the second one is a content creation. We can use about the modeling techniques, LiDAR to capture or 360-degree device to capture. And the content generation part is engaging with the several softwares or maybe special devices for digitizing. And then the contents, we are going to, after making content, how we are going to entertain or experience in 4D experience. Or do we going to connect with the 360-degree VR? Or we are going to concern with the immersive VR environment. Then the content should be optimized. But the today, what we are doing, we just make a three-dimensional object for marketing purpose. We just connect the AR library, just make for the mobile. But the young guys, you are going to open the company. Sometimes maybe you can find to develop you can develop the total pipeline or total solution for AR, VR, XR. Then you can give the different packages for the hardware oriented one or PC based, mobile based, cloud based. Then different services you can carry, you can provide from this uh, digital pipeline. And this is the most important things you have to realize. And then let's see what is our next part is about experience. We need to separate what is the static VR, what is the immersive VR. The static VR, mostly AR and also 360-degree VR, it has belongs to the static VR panoramas 360-degree. They typically, the spherical renderers and also maybe probably markers on the real world contents. It can be replaced with the marker position by 3D objects or 3D character or any other generated object. And they are pretty easy to use. And also then we can extend this one for using different gear VR, providing the created picture render into the right eye and the left eye separately. Concerning about the stereoscopic renderers, we provided the two set of images for both eyes, and then people can feel like the stereoscopic vision in 360 degree. That's what we call that the 360 degree VR. But the workflow may be content generated contents or captured contents, then working in the cardboard, I mean the Gear VR or handphone or tablets. And but the capturing may be not only just the content development tools like a Maya or Blender or softwares, but also we can use the LiDAR or maybe 360-degree drones to capture the environment. This would be really important for the country like Sri Lanka to promoting tourism or maybe heritage sites can use still can use a static VR. And then static VR, the panoramas we can use for design purpose. We can capture and show to customer and get the idea about the environment. But then you can meanwhile make his or her feedback and then try to change it according to the customer feedbacks. Then you can see that a very tiny application, very tiny device, you can get a big change because he or she customer may immerse contents, and then they said, oh, that looks like what I have realized, because space perception of the space is different from 3D to 2D, and he can realize the basic sizes of the objects. And and then there are weaknesses. It is not immersive, cannot move through the space. But I don't say it's the bad. Static VR is not good and static VR is bad. I don't say, but still can use because they're super mobile and it's quite easy to create. That is a strength. The part is how can we make this limited static VR in creative way to acquire um, another, I mean, industry that can fit. And but immersive VR a little bit different, and then it's also provide the stereoscopic 3D standard vision, and also we can workable in the room scale or in a specific measured size. We can get the workable experience inside the generated contents. And the controllers also have maybe not only just the rotating your display, but also we can use the handheld controllers to interact with the scene, maybe teleporting or pointing or selecting for engaging or interacting with the contents. We can use those controllers, but it's immersive. Problem is it's need lot of one side is the cost effective, other thing is need the special knowledge and special arrangement to maintain this kind of contents or this kind of environment. And the immersive VR has a multiple workflows because the transmission through the Bluetooth or networking part, and also the virtual reality toolkits. We have different the toolkits we have. We can use a Steam VR, Open VR, via TK or via SDK. We can use, but also we can use the Unity. For the game engine, maybe Unity. You can use the Unreal. That's why the immersive VR is provide multiple workflow, but generally it's same. It should have the content, the environment by the game engine, and then the via SDK to connect with the virtual reality hardware contents and the data streaming through the networking. We have to use a wireless, some wireless devices, but already some head-mounted displays are already wireless. Some of old fashioned head-mounted displays is still wired. And libraries also, the other part, like assets. So in the libraries we can download to develop, for example, Steam VR and then Oculus Rift or maybe HTC Vive. They have different asset packages to develop the immersive VR contents. And then I will jump this part because and the content generations, typically we are the player, then we should have the virtual inside the virtual scenario. We should have the, let's skip this one. We should have the player avatar or for play games or play with interact with the virtual reality contents. We have to decide it, and the content is the most important thing. We are going to arrange everything inside the box or bounding box or just the virtual reality contents. But sometimes it's not always the same or similar. It's depend on case by case. And but basically it's need the interactivity. It's not just we are looking or visually engaging. And the controlling the virtual reality contents to actively interacting with the contents, we need the controllers. Then immersive controllers, we can make a kind of the control devices. I will show different applications. And then the strength is a fully immersive experience we can get, because moving inside the virtual reality space, it has the ability to interact with the virtual environment, and not the point of view out of the environment, just like a augmented reality. We are looking through the camera, looking through the display, but we are not inside the display. But 360-degree we are inside. Sometimes we are in the center, just rotating our head. But here, experience is a little bit different, workable, and also scalable. The space we can move, or we can interact. And as I said, the most important thing is the scale, understanding the sizes. And the weaknesses is portability, and it's a little bit cumbersome, and then need to know about workflow very well, and need extra experience for the different SDKs to make a contents. And then biggest part for Sri Lankan is the cost of the equipment. It's especially hard to touch these tools because cost. And then for regarding these different type of the devices, I mean different type of stream, different type of pipeline, static VR or immersive VR. The today's challenge, research purpose or research orientation is how can we improve the immersion? How can we make a new dimension for users to engage, or new way of immersion we can provide to user or your customers to engage with the virtual reality contents. And today's main problem is most common type of controllers provide the same type of controllers, like the PlayStation VR or Oculus, HTC Vive. They have controllers. Most of the controllers are the we call active active. It's not a passive interaction, because it's need a guide. It needs to know about which button need to push, which controllers, which hand control. I mean, a right hand controller we use for to shoot, or the hold the contents, or other type of interaction. That means the guidance or providing instruction to user is necessary. But the immersion is a different. Real world, when we are engaging, we are going to temple. Nobody direct us. We know from our childhood, we are going to temple. We can offer the flowers to the Buddha, and then we know that how we can do them. In the way of engaging contents in a passive way is a different person to person, and that part we need to improve. How can we improve immersion? Then there are two ways to improve the immersion. That is, we can call the smart immersive VR. Like interaction, we can use a more passive interaction, providing more the hint or cues for people. They can design, they can do their own way, than active interaction by the guidelines, by the instruction given by the narrative, the narrative prepared narration. Uh, but however, we can use artificial intelligence, AI techniques to concern about user feedback or biofeedback, using the sensors or machine learning techniques or AI techniques to generate the contents. Then it would be more immersive than the template, or the get the interaction by the active instructions. Then let's see how can we use the immersive interaction. The one way is we can use the gesture-based interaction. As I explained earlier, extended interaction, extended VR, they're going to provide our user interaction as we are doing in real life. And then here, just I'm going to show a little bit example. Like sometimes like a leap motion can use the hand for interacting the different way than the teleporting. Teleporting, we just use the pointing our controller device. We can point the location we want to move. Then the virtual traverse, or maybe teleporting, make a dizziness, or maybe via the sickness. It will provide via sickness. Maybe the people would refuse the VR contents due to the sickness of the sickness of the operating method or interacting method. The best way we can use a hand, and when you are working with the gesture or our own finger, it is one of best way we can the navigate contents, what we like, what we comfortable. This application we made for the high performance National Center for High Performance Computing to they can interact with the virtual reality, the server, introducing their server by using virtual reality tour guide. Then we can go through the virtual reality environment. Now you can see that from the space he's landing to Taiwan, and then I'm living in Tainan, the southern part of the Taiwan. This one is in middle part. Then we are on a hand, and we are going through the virtual environment, and it's going to land in front of the building. This is just the screencast. Then it provided some information about the way of we are using our hand. We can navigate the virtual reality contents. I think we have to save some time. I will just a bit skip. Okay, he can close the door and then open the door. And the user can open the door and getting inside, walk through the server room. In the future, it's much more easy with working with the 5G contents, but today you can see the texturing a bit hard to make the very realistic textures because heavy contents. And goes through the one of node, and we can unbox the one of node of the server. Node 3， 触碰伺服机 Node 3的位置。 Then the most important thing is the scenario. How can we organize the inside the graphics and textures? They don't want to show it because this is just for the training application and also the marketing application. They don't want to provide highly sensible details. The can interact with the assembly instructions if they want. Someone want to see the way of their assembling. Okay. It's going to assemble it. I just skip it. And also if he want, he can again see the way of assembly. Try by test mode for the training. Okay, and then you saw that the immersive experience is the way of VR access the contents, touch the content. The tactile feedback or haptic feedback is very important for to improve the immersiveness. And the passive interaction is we don't have the previous one have instruction. The already verbal instruction has and also have instruction on the inside the virtual reality contents. It was labeling. Then people can realize what is the next step. But the contents, if we have like engaging with the content in the virtual reality, we don't have the special way or SOP to interact. When we are the work, I mean the communicating or deal with the pet or companion, we don't have a SOP. I mean a standard operation, step of operation we don't have. We just do our way. And to do that, we definitely need to capture the pressure and the gesture. Then we can make the feedback from the virtual character or the generated device or character according to the user's response. And this is a very small device we made to go to virtual reality environment and communicating. And that can provide the different facial expressions according to the way of we are interacting. Maybe we can touch it, we can shake him, and then companion doll according to our the interaction way. He is going to give the different feedback from his facial expression, transmitting it's wireless device because the tactile feedback with the controllers with the wires it is not easy, and there are several the haptic feedback devices in virtual reality like a Phantom Omni, Novin Falcon. They are very special shape and then special way to interact, and then also it's not a cordless. We are doing some experimentation to introduce the new ways or new companion dolls for everyday life, because extended we are going to be a part of everyday life and going to use to our life, and then we need a communicating device that can communicate in the real world as well as communicate in the virtual world. And then this application was made for simulating the feedback, tactile feedback by using several IMU sensors on the body using the wearable device. And also we introduced the what is called companion doll. It's called Bobo. It's provided the different feedback from his different tail movements, the like emotion, happy, sad, angry, disgusting, surprise. 6 basic the emotions he's gonna give by motions. And then that can be the part of your pet or your the stuffed animal, and also it can be a operating device for you to connect with the virtual world and the real world. And the gesture interactions should give like gesture recognition way, maybe the way of VR interaction. It provides some robotic tail that can integrate or interact according to our gestures. And then now you can understand that the way of interacting, we can do passive interaction techniques or devices, new devices we can introduce for more passive interaction for everyday life. Maybe a doll or a creature or the what you want, you can make. Another thing is generated contents. This application use the you can see that this dog is AI dog. He can decide by himself. It's not just a point. He decide the way we are interacting, and then he can respond according to the the user's uh, interaction. Because of these in a VR animated contents do the same way, everyone can feel same feeling, but different people interact differently, and contents should react according to differently, not always the same way dog is running or same way is dog is moving. And this one is the made by one of our part of our project, what I engaged. The museum application is 5,000 years ago. Dog digitized and made the interactive application. You can download in the whiteboard. I can show later. Mm, and then how to interactive contents. How can we improve the AI contents? There we use some another sample I have prepared for you guys to show. That one generate the sound and its inner feeling by using the open sound communication through the UDP port, that is engaging with the leap motion position and gesture. We train the AI engine. That AI engine can generate the user's sound or motion. You can see here when the way of VR touch we have trained, and maybe the happy, or maybe we are trying to poking, or we are trying to do cheat on him, or maybe different way of interacting. And we train the way of interacting, and then sampling the emotional sampling according to the trained data, and you can see the way. Inner is moving with the motor and tail, mechanical tail, but the gesture-based interaction, then gesture or way of interacting, it generates the different, because a passive character interaction means we don't know how user is going to interact with the character. And then the this kind of new way of interaction or the contents we can train with the AI techniques or machine learning techniques. Then user can have very different experience each time when he is going to interact with the content. The most the biggest problem in the generated content via content, one time they interacting, next time they know that that content is the same, I don't want to interact, I have already tested it. But the contents time to time change, or the way of we are interacting, the contents may respond differently. And this kind of a passive interaction is the future for the virtual reality or extended VR contents. And then now you can understand that the devices are provided somewhat limitation, but to have the extended reality, you should have to develop the contents or interfaces to make it more the extending your reality. The extending reality means not the contents or virtual, but also way of interacting is the most important thing. This is the extended reality glass, the magic leap. It can digitize the three-dimensional, I mean, our real world, and then we can map the virtual world. And the XR glasses are getting famous. And HoloLens is very good, but cost-effective. The challenge from the Magic Leap is the device that can challenge the HoloLens. Now you understood that when we are coming to the virtual reality to or AR, VR content to be a more XR, extended reality, we need to work on three main different things. One is a way of interacting, way of immersion, and then second one is the contents, interfaces, new interfaces, introducing new scenario. That scenario is generated by the artificial intelligence. Then every time we can provide the new experience for the user. And then VR is now kind of the design support tool already. And we can see early age. We have the sketches, maybe the kind of floaters, then engaging with VR. But today it's like the already metamorphosis. We can go back to the contents. We are modeling in a VR, design in the inside the content in the VR, then experiencing in the VR. Everything we will do in a virtual reality, the contents or virtual reality design support tools. And even when I was teaching the animation, I also used the NVIDIA for teaching the animation. And then I designed the content inside the typical animation principles we can teach inside the virtual reality. You can see that I'm inside the virtual world, and then I'm interacting inside the virtual world, and I can generate the different contents. And meanwhile, the storytelling features, we can place the different cameras inside the virtual world, and in real time I can test my vision in the virtual world. This way is the whether this way is suitable for telling the story, or do I need to find another way of camera to introduce it. And therefore the virtual reality is already become a virtual production pipeline, and it's a design tool. Then the starting from the pre-production part, we can do it in a 3D, and the production part we can do it in a VR, and then we can experience it in a VR, and then finally we can export them into the virtual reality world, or maybe by the 360-degree movie, or maybe you can export into the stereoscopic vision. Yeah. Can show into the 360-degree or 2D. We can export it. This is one example I show because it has already become a design support tool. And then this is another tool like a quill. You can search. The quill is one of the software. Many of the users, introduce a new genre in animation, like This is a very greatest artist, Japanese artist, Goro Fujita. He is making many different contents inside the virtual world, and then he made the quite interesting content inside the virtual world. And then he is doing lot of
So let me work on a bridge actually. Lighting it.
Tutorial for entertaining. And then every day he's making 1 or 2 samples to audience. Some of his content is not a bit wacky, and then it's a little bit how to say artistic, and it has art style inside the contents. And maybe this is also one of his work. You can find many of his work inside the YouTube. And this new genre is VR animation or virtual reality animation. And then the contents are like big festivals, SIGGRAPH, Cannes, or other animation festivals. They provide this new category or new genre. And you can see that most of the contents are a little bit low detail because it's working inside virtual world VR. Still hard to do with the very detailed textures, but for the animation, that is kind of like the low detail animation, but still artistic. Then virtual reality, not always using for technology, but also it can use for increase your creativity, because it's providing you on-set experience. You can experience it. This is one of his master class was in maybe SIGGRAPH last time. And then this another one is the TV or VR. That one also can make a very low detail but interesting for the animation. I hope still you can see my monitor. And this one also the same problem happen again. Okay, I think this one also animation too, like that the video has some problem. I would like to go to another one.
Hi, I'm Jose. I'm Alberto, and I'm Wayne.
This is a post VR. This is introduced by the Disney for animating tool.
Post VR was a summer intern that allowed us to pose and animate in VR, as opposed to using a single input device like a mouse in front of us in VR. With the intern, and the rest of the team sort of kicking out that we could animate and take our tools into the future.
We try to focus in creating tools for our artists. With that, we can create content in virtual reality, and one of the things that came out was animation.
I'm just moving things intuitively, and now I'm just thinking about the performance of, okay, what does this pose represent?
Okay, now I think
so
before conclude, I have some other things to show, and that's what I show as a design purpose, design side. And but for therapeutic art or therapeutic way, people used to develop the extraordinary application. The artist Steven made the application to call his mother. This is a draw me close. He want to recall his mother's memory. His mother has passed away, and wanted to interact with the mother with the memories. For you can see that he used a different type of tracking system, that is the VR tracking. He wanted to realize and recall the memory, how he experienced with mom when he was having the problem or ill, and how his mother was creating, and he used some animation like the non-photorealistic rendering contents, because the reality, it's hard to obtain the reality, and to experience the feeling, and also play with the mom and drawing with the mother. That is that title of the creation or application, Draw Me Closer. And the quite range of applications making the VR. And this one is also the recently introduced movie in here in Taiwan, and Our Temple Sucks. Then his imaginative world in one word, and other world is his real life. This is his real life, and then imaginative world. And then translating through the two different spaces can show or narrate what is his mind and what he was thinking, his different experience or his imagination in another world. And then virtual reality storytelling is different from the frame-based storytelling. The content we are looking on a frame or animation or movie is 2-dimension. Even we are going to see the cinema, ViewSonic or IMAX, we are still looking the 2.D, just the content just coming out of the screen, but we are not engaged inside the screen or inside the scene. Then the VR movies is quite different, and then the main thing is we can be inside the contents or be inside the virtual world. Then the still the filmmakers, researchers are still doing that. How can we use the traditional film rules and the narrative techniques, how to use in the VR filmmaking? And one of leading, can you see still my screen? I hope still you can see my screen. Can anyone respond?
Yes, sir, we can see.
Okay, and then this one is the movie recently made a famous director, Tsai Min Liang. He was made his movie in 300-degree shooting, and he used the latest technology to capture 360-degree environment. And then when he was shooting, he used his camera in 360-degree. If we place the camera middle of the room, we just rotating head. We don't know how to direct the viewer or user where to go. We don't know. Then this director, he placed the camera nearby the when he doesn't need.
So we can't.
Excuse me, we can't see the screen.
You can't see the screen.
We can see the screen. It's frozen, I think.
Okay. Okay, now can see.
Not really. No, it's still the presentation slides we can see.
But the screen share is to share. And, is that okay now?
Still no.
Okay, I think I have idea. Because I think can you see now?
For me, no. I'm not sure. Probably not for others either.
No, so we still can't see.
Are you running dual monitors?
I think no. Is it single monitor?
Oh.
Yeah. Okay. I think it's in here. Now I changed the PPT because I screen full screen share. Okay, PPT. Is that okay now?
Still no. Still nothing. No, you can't see just the logo.
Can you see now?
Yes.
Maybe because I think Zoom is prohibited in Taiwan. The restricted, yeah. Connecting from the phone Wi-Fi in schools, we are not allowed to use the Zoom because it's made in China. You know, China-Taiwan conflict. Therefore, regarding security issues, they don't allow us to use the Zoom inside the school. Anyway, I think increase the PPT is a bit heavy. Okay, I think I go back to the main slides. Can you see my monitor right now?
Yes.
Okay. And what he has done, he put the camera nearby the wall. The people, when they are looking the wall, they don't go to the wall direction. Then guiding the virtual world, it's necessary to think about which part we need to show, which part how can we guide the user in the virtual VR movie. This is the way he put. Then he put the camera close to the door. Maybe then when he was shooting, he can test it. Yeah, the director, because of the filmmaking, the director has a director monitor. Then now you can see the director has a virtual glass and he can the check while the shooting. And then you can understand art, films, and the techniques all are going to rewrite their rules and the presentation modes, because the way of we are using still not become like a part of the everyday life. And I think the VR need to be everyday life. It should be XR, extended VR, like the reality should be a part of our life. And then to be a part of life, of course, it should have to use the 5G. Then after 5G environment coming to our world or for the communication mode, then the VR and XR going to change dramatically, or huge difference we can see, because now contents mostly having problems. Some contents like a game content is good because it can do the as they use the web contents, or like a web gaming, they can do that. But for the immersive gaming, we need to do more details, more believable reality. It's quite hard to do that. But today, what we can work with to target in the future, we can use the WebXR or OpenXR. OpenXR is a web mode, and that is the most important thing. Because we can the after 5G coming, we can use the handphones and our mobile device to go to the web mode. And then you guys, as the academic the community students engaging research, can think about the content creation with OpenXR or OpenVR, Open 3D, sometimes called that category introduced earlier Open 3D, but now is OpenXR. You can search on the web, you can find them. OpenXR pipeline engaging with the yeah. Maybe I can show. Can you see my monitor?
Yes.
Yeah, then OpenXR is the way we can do. You can see that the experience, the XR application. Maybe that's what I explained about the optimization. in my early slide about the mode we are going to do, because my early slide I explained this one. Where is it? This one I was explaining this part optimization to different file, different mode. Now you can see the engines are maybe game engine like a Unity, Unreal, and then WebEx are another application. Then application interfaces, you can see there's SteamVR, HoloLens, Oculus, Vive, the Magic Leap. This is the application interface. Then different layers you can find. And now you realize the technology is on your hand, but most important thing is contents. How can we make the contents? And I remember the maybe I was participating. I have been invited for the wearable device summit in the last year in Shenzhen in China. Then we had the panel discussion about how far away are we from the actual consumer VR. And then moderator was the Vive accelerator in China and Israel, the Kevin Leung, and the other panelist Rohit Kanwa from the Huawei, and then the Damon from the Samsung Research. Maybe how can I do this? Okay, here, and Samsung Research, and then I participated, and we were talking about what are the most the consumer, actual consumer we are right now. In this moment, is pornography is the actual consumer product, because the user view contents are fixed. In pornography, people don't change the head, or they don't have the less passive interaction, because the content is fixed. Then the like a pornography already adapted to the VR, and mostly VR and XR contents. But what about the future contents? What do you think? I would like to jump into the discussion, the section, this point. How can you use the actual VR content? What do you think about AR VR fit for what kind of application? Concerning about Sri Lanka or global? Actual consumer VR, we can make application for special industry. Do you have any idea, or can you add something for this discussion? Even the AR, no problem, to make it a more actual consumer product. This moment, pornography is already become a consumer product, but except them, what are the suitable? What are the suitable industries we can use for to make a consumer VR? Practically, how can we use a AR VR for which industry?
Considering Sri Lanka, I think it's probably will be advertising and marketing.
Yeah, advertising marketing. Yeah.
At the start, because that will probably have the budget to such a project.
Yeah.
I am very much interested in storytelling in virtual reality, in filmmaking, but I don't think that will be the start of it here.
Yeah, the film industry is very hard. Still, you know,
it's
still the digital cinema is very hard. There are 30% of the cinema hall is still running the 35 millimeters film in the outside. It's very hard to the digital cinema to engage. And
if you have time, yes, if you have time, check out this link. This is sort of my final project. It's about virtual reality storytelling. That the point that you talked about at the end of the presentation.
Yeah.
Like how storytelling is done in virtual reality. So this is about scripted storytelling. How how a scripted story can be told in a medium of VR, and how we can use virtual reality rather than just you mentioned that that person that who directed that film kept his camera at the corner of the building, so the people won't turn and look at what not the content that is necessary, but the person will look at what's in front of him or her, right? So but the thing is, the issue with that I see is that can be done in contemporary medium as well, like 35 millimeter or what you can say in cinema.
Yeah, I
So
think that the point is maybe point is you know the normal contemporary cinema, we have frame in, frame out, right frame out or left frame out. But here we are inside the VR, then the frame out, frame in, we don't have.
yes,
That is a major difference.
yes,
But the technique is, you are right, we can use the director point of view. But
yes,
here you can see that director point of view and user point of view need to be same sometimes. That's
yes,
why he put the camera near the wall. Then
yes,
user and the director point of view is exactly same,
okay,
but still have the moving space for the person. Then that part still the we call the how to say user identify by himself which part he need. And the after discussion I can send some link of the movies. They use a different techniques. If you're interested, you can email me, message me, I can send some reference. Some filmmakers use a different type of techniques to tell a VR stories.
cool, that's great.
And
And
any other comments about regarding industry,
anyone
film
else?
industry and marketing? Right, good. And fashion industry, you can concern. Except that, regarding entertainment industry, do you think any concerns? What do you think about cricket? Because now in Taiwan and some the the how to say massive tracking systems like the AI, we can track the football player, how player is moving, and then the way of he was moving or way of he is running, and then the coach can see the app and then can get the candidate or get the 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 system suggests that probably this player moved to that side. It is the given by the AI system. That is we call real-time AI system that can connect with the AI, then can get the idea about his players to place in next game or next session to investigating how a player so far played. And this kind of the supporting tool or guiding tool we can concern from the real-time AI connecting with the AI. And also you still I like still Sanat Jayasuriya to play inside the game. If I put my avatar into the game, real-time game, maybe we can replace the we are looking through our device, we can see the older players are playing. And this kind of a replacement, real-time replacement, we can put in the big games like change the head, or you want to be inside the game, then replace yourself inside. This kind of a customizable the application can, if someone can play, we can earn huge money, because selling the tickets for the limited number of seats in a playground, um, it's always limited, but we can sell the millions of tickets all over the world. They can see the cricket match very close to the boundary line, and or maybe in the how to say VIP seat. And we put just a 360-degree camera and in high resolution, and then we can transmit real-time stream the camera into the several users. You and me looking in the same place and looking the game. This is one of application we can think. Do you have any other ideas? Or if you want to go to the discussion mode or concern, I think we can start.